Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we'll take a look at some exceptions to the rules when we deal with absolute value equations and inequalities. And by exceptions, we're really considering some edge cases like when the number is 0 or when the number is negative. In this first example, I've got absolute value of 3x minus 18 equals 0. Now, earlier, when we had an absolute value equal to a positive number, we split this into two equations. It either equaled the number or its opposite. But here, this one's a little different because there's only one number that has an absolute value of 0, and that's 0. So that's telling us that what's inside those absolute value bars has to be 0. So this becomes simply 3x minus 18 equals 0, and we can solve by adding 18 to both sides and dividing both sides by 3. So our solution there is x equals 6. A little side note here, if we had a negative number instead of 0, say we had absolute value 3x minus 18 equals negative 6, the absolute value of an expression is always going to be non-negative. And that means 0 or positive. And there's no way that a positive number or 0 can equal negative 6, so this would have no solution. This is a contradiction. So if you have an absolute value equal to a negative number, there's no solution and you just stop. If you have an absolute value equal to 0, you basically set the expression equal to 0 and solve. You only split it into two when you have an absolute value equal to a positive number. In the second example, I've got the absolute value of x minus 5 is less than negative 4. The number on the right-hand side, once this has been isolated, is a negative number. And again, an absolute value is always going to give us a non-negative result. It's not exactly accurate, but if you think of it as a positive number, right, it's either 0 or positive. But if you just think about it as a positive number, can a positive number be less than a negative number? Impossible. A non-negative number can never be less than a negative number. So this one has no solution as well. If this had been absolute value of x minus 5 was less than 0, that would have no solution as well, because less than 0 is just another way of saying negative. If it was less than or equal to 0, you would take the expression inside instead of equal to 0 and solve that. Maybe I'll do that as a bonus problem. Suppose you had the absolute value of x plus 2 less than or equal to 0. What I said was you would take x plus 2 equal to 0 and you would solve that. X would be negative 2. We wouldn't have to worry about the less than part, just the equal to part. And again, without the equal sign, absolute value x plus 2 less than 0, that has no solution. All right, one more to go. We dealt with the equal sign, we dealt with the less than sign. This one we're going to take a look at one with the greater than sign. And this is trouble in hiding. It doesn't look like trouble just yet, but the absolute value is not isolated yet. And when I subtract 13 from both sides to isolate the absolute value, I now have the absolute value of x plus 8 is greater than negative 6. And again, this absolute value is non-negative, or again, it's 0 or positive. A non-negative number greater than a negative number, that's true all the time. That's an identity. And so this would be the set of all real numbers. On a number line, you would shade the whole line, and including the arrows. And in interval notation, it would be like that, negative infinity, comma, infinity, all in parentheses. All right, so that dealt with some of the odd cases when we're dealing with absolute value equations and inequalities, specifically when we're comparing them to either 0 or a negative number.